Linear equations are everywhere in business. This video will take a look at some of the fundamental analytical principles behind some key equations. Then we will reinforce these concepts with fairly simple examples found in real business contexts. Many of you may be familiar with the mathematical equation for a straight line, which is y equals m times x plus b, or y equals mx plus b. It could just as well be written as y equals b plus n times x. Here, y is a variable that we are interested in finding a value from another variable, x. M, as you may recall, is the slope, and b is the y-intercept, which is where our line crosses the y-axis. As you can see, our linear equation crosses the y-axis at our starting point where x equals 0 and y equals 3. The line then rises upward as we move along the x-axis to the right, where y increases 2 units for every 1 unit increase in x. The concept of the change in y that results from a single unit increase in x will serve you well in understanding higher levels of analytics, regression analysis in particular. Let's look at an example to further illustrate this point. Most CEOs will tell you that their sales team is the lifeblood of their business. They are usually compensated very well, often at the chagrin of other employees. But anyone who has been in sales can also tell you that it is not an easy job and not for everyone. To provide an incentive to sell more, many companies pay their sales teams on commission. That is, the more they sell, the more the salesperson makes in income. Now, that can often lead to quite a bit of variation in a sales rep's pay or compensation. So many companies pay their employees a base salary plus a percentage of every dollar that they sell so that they have some money to live on each month. Also, note that this compensation plan can get quite complicated. We will look at a simple plan at this level. Let's say, for example, that our sales team gets paid $3,000 per month, plus 6% for every dollar that they sell. That becomes a linear equation that looks like this. So the first question we might ask is, how much money will I make if I sell $40,000 in 1 month? We can use our linear equation for compensation to figure that out. We plug in $40,000 for sales, or x, and then multiply it by 0.06, which is 6%. That will result in a total compensation of $5,400 for that month. I could also use this equation to answer the question, how much would I have to sell in order to earn at least $8,000 per month? This rep might be a little greedier, or have a large family to feed, or have some expensive tastes in cars, etc. You start by plugging in $8,000 for compensation y, and then you solve for sales x. First, I subtract $3,000 from both sides to get this equation. Then, I divide both sides by 0.06, which is 6%, from both sides to get the following equation. That results in a monthly sales figure of $83,333.33 that I would need to sell to make $8,000 in commission for that month. My goal here is to keep the math as simple as possible, but give you a feel for how the calculations work. Here's one more example. Let's say that I have another opportunity to be a sales rep at a company that offers a lower base but a higher commission rate. Here, the base is $2,000 and the commission rate is 8% of sales. What should I do? Let's use some analytics to find out. I created this table of both values using compensation plans to help me. As you can see, I make more money with the first plan until I hit the $50,000 sales level. Then I make more money with the new plan. What would you do? What do you think most sales reps would choose? This graph summarizes the decision nicely. Most sales reps tend to be very optimistic and a little greedy, so they are likely to go for the new plan. As a manager, you should be aware of this when thinking about creating commission-based compensation plans to incentivize your sales staff. Keep in mind The second plan is going to be more costly to the company, but it's usually worth it in terms of higher sales.